Why we chose the T3 stack at Zoom. This is an article I am very excited to see. Ekaansh has been one of the coolest community members for a while now, and I believe late last year, maybe more recently, he moved to start working at Zoom to help them with all of their SDK stuff. Zoom's trying to build more tools for developers to include their WASM servers in their applications, and let's be real, they baited me into looking at this because they're using T3 stack and I have to take a look. So I'm not being paid for this. I have no affiliation with Zoom. We're not even using them for paying. We're using a competitor. But after this, I might actually consider changing that because I'm pretty hyped to see what has led the Zoom team to considering T3 stack for a lot of the stuff that they've been building. So let's dive in. At Zoom, we want to empower developers to build innovative and engaging products with the Zoom SDKs. To give them a head start, we're creating a series of reference apps across different verticals to give them a good starting point to building their own apps. There's a lot of debate around the best way to build a web app on the internet today, but this is a blog that isn't about that. We'll walk you through our process of selecting the technology stack to build reference apps and why we decided to go with the T3 stack. Ooh boy. What's a stack for reference apps anyways? We wanted to ensure that our technology stack would be useful for as many developers as possible. For example, we could consider building our front end in Rust to make things blazingly fast, but it would be useful for a much smaller subset of our potential developer audience. Don't stuff Rust where it doesn't belong. Maybe using WASM stuff for encoding and decoding video efficiently, maybe, but the built-in browser primitives are going to be better for that anyways, and you shouldn't be doing that in JavaScript. So yeah, Rust for front end does not make sense. Rust for doing some types of compute on front end occasionally perhaps makes sense. Yeah. When building for the web, it's hard to justify using anything other than JS. However, the lack of type safety, among other drawbacks, made us pick TypeScript, which is a superset of JS. Yep. If you're building a library and you're building examples, please use TypeScript. If you write TypeScript well, then most of the type definitions shouldn't even carry into the code copy-pasted. And even then, they're very quick to delete. So if I do happen to be one of those few devs that's refusing to adopt TypeScript, having TypeScript examples isn't particularly at cost because you can still just delete the little bit of type def in the file. So yes, all examples at this point should be in TypeScript. TypeScript simplified the process of writing and managing the app within our team, ensuring seamless collaboration on shared features across both front-end and back-end components. Huge. This is one of the biggest things about TypeScript, and it's why Microsoft made it. They needed the ability to make sure when things change, when lots of devs are working on them, that doesn't break shit unexpectedly. And if you're building an SDK that's being used in a lot of projects, it's really nice to have a repo with a bunch of those projects in it, just using all the functionality. And then when you change something in the package, you'll immediately get red squiggly lines and type errors and build errors because some of that code is expecting things that either do or do not exist inside of that package. And being able to change a type signature or deprecate a function and immediately see what's affected, necessary if you're a library dev. It still is painful to make good types as a library dev. If I've learned anything with upload thing, it's that, but the benefits are so great too. It does add extra syntax though, and as the article says here, it can be intimidating for devs that are unfamiliar with the language, but the code still reads the same as JS, and most of the added syntax can be skipped over while reading through the source. Yep. There's plenty of people whose brains just turn off at the type definitions and only read the actual code, not the things describing the code's type definitions, just the actual logic. And you can still read TypeScript just fine. Expanding on the core idea of choosing tech that with the widest application, we chose React. It is still the most popular framework library to build for the web because of the simple programming model and composing of components. Yep. It's really hard to justify having your main example not be React at this point, not just because React is the most popular, but the React ecosystem and the React developers are the most willing to adopt new tools and solutions because we built such a modular space. Since React doesn't come with solutions for a lot of these problems because it's really just a rendering library, there's now a culture around adding and removing parts, almost like Unix style. So it makes perfect sense if you're building an SDK to make your examples using React. While the Zoom Video SDK uses JWTs for session authorization, which makes it compatible for any backend or framework, we limited our backend choices to those written in TypeScript so our audience wouldn't need to know another programming language. Another huge thing. Yes, a lot of companies probably write backends and things that aren't JavaScript. Obviously. I'm not saying that's a bad thing at all. What I will say is if I'm working at a company considering adding something like the Zoom Video SDK, the person who's going to explore that and play it out is probably leaning towards front end. They might do some backend dev, but it is not their strength. The person exploring the Zoom SDK is almost certainly front-end leaning, so making sure the backend part of the examples is something they don't have to learn more about, huge. Very, very helpful. And I don't think it should only support JavaScript backends, but I think the examples being structured for the people who are going to be reading through it and making these types of decisions, that makes a ton of sense. Totally agree there. To build a full stack web app with React, we chose Next.js. It does a great job of abstracting away the complexity in web tooling, both for the front end as well as for the back end. Now we're set with a solid foundation. Good pun. Yeah, it's technically React, not solid, but yeah. So what's next? Literally, capital N, next. Clever. React and Next set the foundation for our reference apps, but we still have to answer some certain questions, like what about the database, or how do we handle auth? Before we could answer these questions, we need to decide whether to use open source libraries for these features or develop our own from scratch. If you can use open source libraries, you almost always should, especially for things like auth. Ooh. Choosing a specific library requires that the developer using the reference app understands how the library functions, potentially creating a barrier to entry. However, we quickly realized creating our own implementation would present greater challenges for developers. For example, to make any changes, devs would have to read the source code to understand our way of handling auth. With an open source library, the user can simply read the library docs instead when needed. Avoiding reinventing the wheel would also allow us to allocate our time towards building more apps for different verticals. I like this too. This is actually one of the best cases for a stack that's particularly flexible. If you want to have a bunch of reference examples and you're literally changing projects every week or two, greenfielding a bunch of stuff, something like T3 Stack makes a ton of sense. And I'm very excited to hear how it's worked out for them. So what is the T3 Stack? T3 Stack is built for Next.js and TypeScript. Most projects will use the additional T3 Stack recommendations like Tailwind, tRPC, Prisma, or Drizzle, Nextauth, or potentially Clerk in the future. You get the idea. If you haven't already seen create.t3.gg, best way to start a full stack type safe Next app. And we have all of these things listed. We should add Drizzle and restructure the homepage in the near future. We'll get there. Anyways, they also recommend using our CLI and our docs. Love they're calling that out here. If we started with a new Next project and chose from the available libraries, we'd end up with something similar. The T3 Stack made it easy for us to start without having to set up every single part ourselves. The option to use the newer app router in Next was recently added to the T3 Stack as well. We decided to stick with Pages Router for now. Also, totally acceptable. I know a lot of people are going to think, oh, Theo, you're the Next.js server component app router guy. What do you mean you can use the old legacy Pages Router? Isn't that deprecated? Are you recommending Next 12? No, Pages Router is great right now. I still have a lot of projects that are either built entirely on Pages Router or still rely on Pages Router for a bit of functionality. It's a fine solution, and it's very well supported, and it is still a default in a ton of things for a reason. I like App Router and the new patterns, but Pages Router is totally fine to use to this day. There's actually a few projects that I almost wish I had started with Pages Router, but I've made App Router work how I need it to there. But yeah, App Router is both more flexible, but also has way more foot guns. Pages Router has a couple massive foot guns, but once you learn to just never use those features, it's a little bit easier to use on a team, especially a team that's newer to the patterns and functionality. Styling. Tailwind. Yep, just use Tailwind. At this point, if you have a disagreement with Tailwind and you haven't used it for more than a week yet, just shut up and try it. Give it an honest go. I hated the thought of Tailwind when I saw it. And then I used it for a week. And now I'm one of the biggest Tailwind proponents. It just solves so many problems with styling. It's insane. We also use ShadCN UI for the UI components to save time on writing the UI while still owning each component as part of the source code. It is accessible out of the box, and we can allow devs to easily change the theme according to their brand. Yep. Shad UI is so nice for this. Auth. They're using Nextauth. Awesome. Nextauth's a great solution. There's also new ones like Lucia Auth, and obviously the sponsor of the channel, Clerk. I think Clerk's easy to set up, but right now, Nextauth's the only option inside of Create T3 app. That might change in the future, and editor's note, if that has changed by the time it's coming out, we'll stick that somewhere in the video. Anyways, database and ORM. We knew we'd have to use a SQL database for storing user data. Well, you could use other things, especially if you're using Prisma, because technically Prisma works with Mongo, which was miserable for them to make work. But anyways, they chose Postgres as it's one of the most commonly used open source databases. To keep our DB queries type safe, we also need an ORM. Prisma's still the default in Create T3 app. We should move it to Drizzle. Prisma's fine. It's not as fast or nice and modern as Drizzle, but Prisma's still fine. And the star of the show that brings it all together, tRPC. It blurs the line between the front end and the back end in the best way possible. I introduced it to the team, which was apprehensive at first, but they quickly fell in love. I love that, because this article is as much Ekaansh sharing with us as devs what their experience is and why they chose this, as much as it is him telling the story of how he convinced the team of these things too. And tRPC makes these types of things so much easier. The relationship between backend and front end can be its own field. Like you can have whole teams at your company where all they do is design the API layer between the backend and the front end in a way that works and scales. tRPC just does it, and it does it great. Like GraphQL, to do it right takes a team of 5 focused on it, getting it right. tRPC just does it, and it's smoother and faster and way easier to work with. And it has so many crazy magical superpowers. Like for an example, here's a project I've been working on. It has paginated data on the homepage. Well, the view page. I'll just go to it in the browser. It's the project that I'm working on right now to manage all my thumbnail faces. And it has infinite scrolling. I hit load more, and it loads more. I'm on a VPN, so it's a bit slow. But adding that functionality is super simple. And I could even make it just trigger when you get to that point in the view. I'm lazy, we'll get there. But the actual code to call that is so simple. Here I have data, fetch next page, has next page, api.images.getPaginatedData, or getPaginatedImages.useInfiniteQuery. This is just React query. tRPC's React bindings just wrap React query with the tRPC bindings. So API is just my name of the tRPC helper. If I want to get other things, it's just API dot. And notice that it auto-completes. Image dot, get latest, get paginated. It's all just there. All the return types, all the input types, all of that is all type safe. But the magical feature, the thing that blew me away when it got added in V10, what if I want to see the source code on the back end here? Because this is just an API call. All I have to do to see that, command click on get paginated images. And now I'm in a backend folder. See, we're now in source/server. This is the API itself. It has an input, which is using Zod to validate to make sure we're actually passing it the right thing. And it has the query, which is the actual function that runs when we call it. Whatever we return here is now going to be type safe in the actual definition that gets used on the client side too. So whatever I return here, I now know that type def here. The infinite data is the data coming from that return. In here, I'm using the context as my way of accessing the database. I could have just imported DB directly, but having it bound to the context is a nice convenience. So context.db.query.uploadedimages.findMany, where grab the model, grab these helper functions, filter things, make sure it's the right user, push all the checks I want to do when I actually fire the query, and return it with an and wrapper. Relatively simple. This is super handy. But the thing you'll notice here is most of the code has nothing to do with tRPC. It's just writing TypeScript. Like I'm just writing what I need to do. There's no type definitions there. In fact, if you look closely, you'll notice there's no type definitions in this file. This is technically a vanilla JS file. No types here at all. The magic is that using Zod as a validator and using TypeScript's inference when you return results in the thing being done here being fully type safe just from the validation on the front and the return type on the back being auto-defined through inference. So it's that easy. If I want to make a new endpoint, simple example. I can make it a protected procedure, which is just a wrapper around a procedure that requires you to be auth. I won't even bother for this one. So we'll do public procedure. In this one, we could have an input. It's as simple as dot input to give it one. Perfect. We'll just autocomplete it. Cool. I like making it as part of an object. So we'll do that. Z.object. I'll call it message. So now this takes an input of a message string, and then it returns it. We can say hello plus that. Well, sorry, it needs to be input.message. Cool. If I want to call that, it's actually quite simple. Const example equals API.image. And it all just auto-completes. Simple, use query, message, cool. An example.data, if we hover over it, the type's going to be string or undefined because it's possible it hasn't loaded yet. But if it's loaded, we know the result is a string. And what's really cool here is if I change something here, like I change this to be wrapped like this, response, I don't even have to save the file. I'm leaving the file not saved. And here you can see the type already changed. So if I do data.response there, and I change this over here to be message instead, without even saving the type error, because this is all happening in TypeScript's virtual like type checkers. This is all happening in the TypeScript instance running in VS Code. We don't need a build check. We don't need all these other steps. It's just using the inference built into TypeScript, which is why tRPC is so powerful. Instead of defining an API like service between your backend and your front end, tRPC is using TypeScript as that service, as that API layer, as the documentation for your API. And it's so good. It's so good. If you can be using tRPC, you absolutely should be. And every time I don't use it on a big project, I ended up regretting it and adding it back in, including this one. I just rewrote this entire project so I could do it with tRPC instead, and it's made life so much easier. Anyways, you already know I'm a tRPC show. There's a reason for it. Hopefully this helps emphasize why. Back to the article. It allowed us to work individually on the same features across the stack without having to worry about someone else's code. Not only does this make collaboration effortless, it also makes reading and navigating the code a lot easier. Couldn't agree more. Especially, again, when I want to see what this backend code does, command click, now I'm in the backend code. Having that in like very front-end heavy code is magical, and it makes refactors, it makes big changes, it makes reading code reviews and playing with things just all so much easier. If you're unfamiliar with any of the tools mentioned in the blog, you can find great explanations and guides for each piece in the T3 Stack docs. There is a huge community building and using these tools, and we're excited to be a part of it. Huge thanks to everyone who's building open source tools, and especially the contributors behind the project. We care a lot about developer experience and developer productivity, both internally and externally. We want to make sure that our reference apps are using modern tools that are easy to build with as well as maintain, both for our teams and for yours. We think these tools strike a great balance between impacting most devs and being easy to build with and maintain. They even have a link here, the intro blog, showing some examples, all awesome stuff worth checking out. I'm hyped on this. Huge shout out to Ekaansh once again for getting this opportunity and taking it. Like, joining a big company like Zoom and pushing changes like this is terrifying. To be doing it as early in your career as you are is so cool. So like, huge shout out to Ekaansh. Give him a follow on Twitter. He's killing it with the DevRel. He just convinced me to showcase Zoom's SDKs in front of however many tens of thousands of people. So clearly he's good at what he's doing. And until next time, peace nerds.